problem number 4, Gari has between 50 and 100 pennies. She stacks them in piles of 2 and she has 1 penny left over. When she stacks them in piles of 3, she has 1 penny left over, and when she stacks them in piles of 4, she has 1 penny left over. However, when she stacks them in piles of 5, there are no pennies left over. So the question is, how many pennies does Gari have? Alright, well, Gari is actually one of my students whom I'm hoping to see this Saturday in my class. So, hi Gari, I hope you had a good time in India if you're watching. So, anyway, let me go ahead and let's see. I suppose I should give you a hint first, right? And it all, it all comes down to the divisibility rules. And probably the first thing you should look at is that when she piles these pennies into piles of 5, she has no pennies left over. So we know that the number of pennies, let's call that n, is divisible by 5, okay? And so if you know your divisibility rules, you know what the last digit is of that number, the number of pennies. And so that can help you narrow down the possibilities, okay? And, we also know that she has 1 left over when she stacks them in piles of 2, 3, and 4. So we know that the number is not evenly divisible by 2, 3, or 4. So using the divisibility rules, we can just gradually eliminate some of the possibilities and narrow down the number that we're looking for. Alright, so let me go ahead and solve this. I actually have 2 ways to solve this. One is the way I solved it, and I also gave this problem to my son and let him solve it, and I can show you how he did it. I think his way is a little bit quicker, so I'll show you that way too. But here's what I did. I said, okay, I know it's divisible by 5, and I also know it's not divisible by 2, so it has to be an odd number. Now, numbers that are divisible by 5 end in 0 or 5. But if it ends in a 0 is even, and then when she piles the pennies in stacks of 2, she wouldn't have any left over. So it can end in 0. So it has to end in 5. So there aren't very many numbers between 50 and 100 that end in 5. We can list them out. We'd have 55. We'd have 65. We'd have 75, 85, and 95. Okay, so we only have 5 possibilities for the numbers. That narrows it down pretty quickly. So let's take a look at if we divide any of these numbers by 3. Now none of these numbers, well actually 75 is actually divisible by 3, right? Because we can look at the sum of the digits and you can see that they add to 12, which is divisible by 3, so this one has a remainder of 0. Okay? And if you were to divide 55 by 3, you actually get a remainder of 1. When you divide 65 by 3, you get a remainder of 2. You can see that because 3 would go into 6 twice, so you get 2, and then 5 minus 3 would be 2, so you get a remainder of 2. Okay? And if we look at 85, we have a remainder of 1. And if we look at 95, we have a remainder of 2. So you can see too there's a pattern in the remainders. Okay, so that narrows it down even further because we know that when she stacks the pennies in piles of 3, she has 1 left over. So that means the remainder when the pennies are divided by 3 is 1. So we know now that it can't be 65, it can't be 75, and it can't be 95, okay? The only ones that have a remainder of 1 are 55 and 85. So let's look at, let's see, we've taken care of basically 2 and 3, and the only other one is 4. So let's take a look at divisibility by 4. If we divide 55 by 4, we actually get a remainder of 3. Okay? And which, you know, tells you that if you were to stack the pennies into stacks of 4, we'd have 3 left over, not 1. So it can't be 55 either. So we're only down to 1, and so we can test that. If we divide 85 by 4, we get 85 by 4. Here I wrote 84. 85 by 4, we get a remainder of 1, right? So we get 21 stacks of 4 and 1 left over. So our number has to be 85. Okay? Now, let me show you how my son did it. I think it's a little bit quicker. So I'm going to draw a little dashed line here. So he also looked at it and said, okay, it has to end in 5 because it's odd and it's divisible by 5. So the number has to end in 5. But then he noticed that if you were to take n minus 1, okay, so n is the number of pennies. We said n is divisible by 5, but n minus 1 has to be divisible by 12. And that's because it's when we take the pennies and we divide them into stacks of 3, we have one left over. And when we divide them into stacks of 4, we have 1 left over. So if we took away 1 penny from the total number of pennies, then when we would stack it in piles of 3, we would get none left over, right? Because we took away 1. Same way with 4. If we stack the pennies in stacks of 4, we'd have none left over if we took away 1. Okay? So what he recognized is that n minus 1 is divisible by 12. So then he listed out the multiples of 12 between 50 and 100. And so his numbers were 60, which is 5 times 12, 72, 84, and 96. Okay? But we don't want to know n minus 1, we want to know n. So let's add 1 back into these piles. So we'd get 61, 73, 85, and 97. And we already said that it's divisible by 5, and it has to end in 5 because it's not divisible by 2. So that tells you that the only number that ends in a 5 is 85. So that is actually a little bit quicker, I think. You don't have to do all these division and find remainders. So either way, it comes up with the same number. But sometimes it's good to see how other people solve things, because you know, you get some good ideas. And so there you go. There's the solution. 85 pennies.